Hi, I'm Douglas. I'm a software engineer at Nutrient, and I'm going to show using the Nutrient Data Extraction API. So from the Nutrient website, we're going to go to Cloud and then Try. This takes us to the Nutrient Document Web Services dashboard where I'll sign in with my Google account. We're currently on the Processor API, so I'll switch over to Data Extraction. And we're going to use the Studio to get started, where we can see the API in use in our browser and experiment with different options. We can see that there are two APIs as part of data extraction. We have parse, which gets the full text out of a document as either JSON or markdown for further processing, or we have extract, which just pulls out the specific information that we define from a document. So let's start with extract. Let's load up an invoice. So we're going to look at 3 invoices that Nutrient has received from different vendors, and we will extract the same information from each one. On the right-hand side, we have the configuration, which defines the data extraction operation that we're going to do. The most important part of this for extract is the schema. So this defines the specific fields and the types of that information that we want to take from the document. This schema is actually already for an invoice, but it has more fields than I want to include for this demo. So to make things a bit simpler, let's clear that. And we can type in what we want. So we could put the label like date. We can define the type. So we support nested types, but we'll just use date for this one. And then to set exactly what type of information that it is and isn't, we can say like the date the invoice was issued. So not, for example, the date the payment is due. Then we can continue adding properties, but rather than watching me type all those in, there's a schema here I made earlier. So this one is actually, it's just JSON, that's all I imported, but it's a bit easier to read in the builder. As well as the date, you can see I've added the invoice number, the company that issued the invoice, the total amount, which we set as a number, and the currency of that total. And you can see some of the descriptions are quite detailed. I found by experimentation how to be clear about what we want so that it works across a range of documents. And I will just set the mode to understand. That's the trade-off between the quality and the speed and cost. And we could use a slightly faster option in this case. We can see we now have the results on the right. As I hover over these, we will see a citation back over the document on the left, showing where this information came from within the document. So this will be useful for auditing that extracted data. We can also see the actual JSON that the API has responded with. So you can see that those rectangles where the text came from are available in the JSON as well, because everything we see here in the studio is built on top of the API. Okay, so that's fine for a single document, but things get a bit more useful when we can apply the same schema to a different document. So you can see this one is from a different vendor, has a different layout, but we can still pull out the same information. So we can see we've got the fields we requested as before. We'll look at one final invoice. This one is a bit different. You can see that while the others were fully digital, this one is was at some point printed, and then it's had a photo taken of it to scan it in. So this is fine because the data extraction API will do character recognition. It works very well for printed text like this, but it will also work with handwriting, although you may see a lower accuracy in that case, so you might want to have more manual checks in place for handwriting. Right, so we can see we've got the information that we requested as before with the citations. And yeah, that's all I wanted to show from extract. So let's use the other API we have here, which is parse. We will load in just a single page from a financial document. You can see that the configuration for parse is much simpler than extract because we don't have a schema. The most important part is the mode. So as I said, it's the trade-off between speed and quality. Agentic does the most analysis of the layout and, for example, will recognize text within logos and other graphics, as well as just recognizing the overall page text. Understand is also a very good option, but it's a little bit faster than Agentic. And then there are some other options like whether we want to have the tables as markdown or as HTML. Let's say we want to have them as markdown and run that. So you can see that what we get back from parse is a list of blocks of text within the document, which are in the natural reading order. Each block is assigned a role, like whether it's a heading or regular text or a table, including its rows and columns. We can also look at the complete markdown representation of the document. So as long as the document is not too long, this would be a good format for passing to a large language model. For longer documents, you of course have access to the same markdown, but split up in each block with, again, the JSON we saw before. And then we've got also the markdown rendered nicely here. So let's just do one final document. So this is another page from a financial report. And we'll just see here that this chart in the middle is picked up as a picture. So it's preserved in the results alongside the text elements. So this is all I wanted to show in the studio. This is a good place to try out different documents with the different modes and work on the schema to make sure it's extracting the particular information that you want. Once you have tried that out, you could then integrate it into an actual automated process in your code. So we have examples in a few programming languages here showing making the API calls to data extraction. So you can set up your process.